What is a gear and rack? Any other names? A gear and rack, also known as a rack and pinion or pinion and rack, is a mechanical system comprising two essential components. 1. Gear pinion, a small circular gear with teeth typically mounted on a rotating shaft. 2. Rack linear gear, a straight bar featuring evenly spaced teeth that engage with the pinion's gear teeth. Other common names include rack and pinion, drive common in automotive systems. Spur gear rack refers to racks with straight-cut teeth. Linear gear mechanism, emphasizing linear motion output. Double gear rack systems using two parallel racks. Rack and pinion systems are commonly employed to transform rotational motion into linear movement. The gear rack, featuring straight teeth cut along one surface of a rectangular or circular cross-section, works in conjunction with a pinion, a compact cylindrical gear that meshes with the rack. Typically, the gear rack and pinion are referred to collectively as the rack and pinion mechanism. The use of gears is diverse. For instance, as depicted in the figure, a gear engages with a gear rack to rotate a parallel shaft to cater to diverse applications. TOCO maintains an extensive inventory of gear racks. In scenarios necessitating a prolonged rack length involving multiple gear racks in series, we offer racks with precisely aligned tooth forms at the ends, known as gear racks with machined ends. During the manufacturing process, tooth cutting and heat treatment may result in dimensional variations. We mitigate this through specialized pressing and corrective procedures. In certain applications, the gear rack remains stationary as the pinion traverses, whereas in others, the pinion rotates about a fixed axis while the rack moves. The former finds widespread use in conveying systems, while the latter is applicable in extrusion processes and lifting-lowering mechanisms as components for converting rotary motion to linear. Gear racks are frequently juxtaposed with ball screws. Each has its advantages and disadvantages. Gear racks offer simplicity in design, substantial load-bearing capacity, and the flexibility of unlimited length. However, backlash is a drawback. Ball screws, on the other hand, ensure high precision and minimal backlash. Though their length is constrained by deflection concerns, life expectancy of a rack and pinion. The lifespan of a rack and pinion system depends on factors such as material quality, load conditions, maintenance, and operating environment. Well-designed systems with proper lubrication, protection from contaminants, and regular inspections can last 10+ years. However, high-stress applications, for example, heavy industrial machinery or inadequate maintenance may reduce durability. Timely replacement of worn components and preventive care are key to extending longevity. Function of gear and pinion rack and pinion. The primary function is to convert rotational motion into linear motion and vice versa. When the pinion rotates, its teeth engage with the rack's linear teeth, causing the rack to move along its axis. This enables precise linear displacement control. Key applications include automotive steering. Rotating the pinion turns the steering wheel, translating motion into wheel movement. Industrial automation, CNC machines, elevators and robotic arms use this mechanism for accurate positioning. Transmission systems, gear shifting in vehicles or machinery. Linear actuators, converting motor rotation into linear force. The system's efficiency and reliability make it ideal for applications requiring both power transmission and precise linear travel. which is rack and pinion. In a rack and pinion system, rack, the linear component straight bar with teeth running along its length. It acts as a guiding track that translates rotary motion into straight line movement. Pinion, the rotating gear with teeth that mesh directly with the rack. When spun, it drives the rack forward or backward, effectively converting rotation to linear displacement. Key features: motion conversion. Rotary gives linear or reverse precision. Teeth engagement ensures synchronized smooth movement. Versatility, adaptable to various load and speed requirements through design modifications, for example, helical racks for quieter operation. Commonality, ubiquitous in steering systems, industrial automation, and beyond. In summary, the rack and pinion is a robust, efficient mechanism that bridges rotary and linear motion, enabling precise control in critical applications. Its durability, adaptability, and widespread use across industries make it a cornerstone of modern mechanical engineering.